Morning, boys and girls. So I'm making this video for a snap circuit activity that you'll do today on our asynchronous day, Friday, January 8th. It's called the snap circuit activity, the light emitting diode, LED. That's what it stands for. So this is going to be a Google slide that I'm going to post as an assignment. So it's not posted. It'll be posted by the time you see this video, but this is the activity. So we're going to build Project 7 and Project 9 today. And I want you to watch this clip because in this clip, it'll give you some directions on how to complete this activity. So I posted a video within this presentation. And the best thing to do when you open this slide, if you want to see it larger, is to click the present button here. Now remember, sometimes in Google Classroom, you don't see all of your menu options. So if you click on this little arrow here, it'll open up more menu options, and then you'll see this word present. This will allow you to see it in a much larger way. And that'll be important, especially when you're playing the video. And if you click play, this is a YouTube link that's in here, and it talks a little bit about what LEDs are. But I'll let you play that later, and you'll need to watch it because there'll be some questions about what's in the video as well. So,
in the late 1800s, Thomas Edison invented the...
Sorry about that. So we're going to go to the next slide, which is Project 7. This is also in your book, and it's called Light Emitting Diode, and the objective is to show how a resistor and LED are wired to emit light. So we're going to learn a couple of things today. We're going to learn how to learn what a resistor does, which is this item here, this component. It's called R1. So this has a 100 ohm resistor. What a resistor does, it slows down the flow of electricity. And oftentimes when you're working with LEDs, which is this red light here, LED lights work differently than traditional bulbs. LEDs generally are brighter and they require less energy to perform the same task a regular bulb can do. What the resistor does is it protects the LED from burning out. What you would never want to do is, if you have a battery pack like this, I'll snap these batteries in like so. You never want to hold, this is a traditional light bulb, and see how I can put that over that, right over the battery. You don't want to do that with an LED because one, you'll burn it out, but since this is a low voltage situation, it just won't turn on. So I'm not going to do that because I don't want you to try it at home, but the resistor is going to be used in this circuit so that the LED light will not burn out. The other thing about LED lights is that it has what's something called polarity. So you'll notice that there's a plus sign here. If you do not connect the LED properly in the circuit, it won't turn on as well. The electricity has to flow in this direction in order for the LED light to work. It can't flow in this direction. So we're going to put the Project 7 together. Now, something you should notice in the directions, you'll see these small little numbers here, like 1, 2, 1, 1, 1, 2, 2. Those small numbers in black tell you what to put down first. So the battery pack should be put down first. So between C and E, 5. With the plus sign up. So here's 5, and here's C. So I'm going to place it down like so. The next thing we're going to need is the LED, which would be at F5, and the plus sign should be on the left. Right, if you flip it like this, with the plus sign over here, it won't work. The plus sign is here for the battery pack, so the plus sign has to come first, which should be on the left, like so. Then we have the resistor. The resistor is from C to E3. So that will be right here. And then we have the switch. And what the switch does is allows us to open and close the circuit. We learned about that in our previous lesson. So I'm going to connect that between B3 and B5. So you'll notice we've already kind of set up the path here, right? So now I connect, make sure this is in the off position. I use my 4 2s and I'll connect it like so. Okay, now that everything is connected in one path, I could turn on the switch and you see the light comes on. And the resistor here ensures that as the electricity is flowing, right, it slows down the flow just enough so that this LED has the proper amount of current. Now, remember I told you if you flip it around, so you can try this now. I'll disconnect these. And I flip this so that the plus sign is now here. And then I reconnect it. The light should not come on. So, unlike a traditional bulb, see I turned on the switch. Unlike a traditional bulb, LEDs have a plus and a minus side, just like a battery does. So you have to make sure that the LED is plugged in properly. Okay, now that you've now that you had a chance to put that together, from the video, list 3 to 5 items that use LEDs. So think about your house. In my house, my Christmas tree has LED lights on it. My ceiling fan has LED bulbs, and that helps to save energy actually. Some cars have LED headlights. So you can actually search this up, but in the video they mentioned several things that uses LED lights. Now we're going to do something, we're going to do project 9, and basically it's project 7 without the switch. And what you're going to do is you're going to figure out which items in your house can be used as conductors to allow the LED light bulb to light up. So basically it's the same circuit, but I'm going to remove the switch. And essentially you're going to find an items in your house that can act as a switch. So right now I'm missing a piece that I can connect to these 2 terminals to allow this bulb to light up. Now if I were to touch the 2 tops, if I were to touch the 2 metals, which is going to be kind of tricky to do, there we go. See how the light bulb turns on? And if I touch the bottom of this 2 has a metal piece. So what we're going to do is we're going to find some items in our house. So I'm going to bring that over. I'm going to place them here. And I just went around my house. I found items big and small of all different types of materials. Loose coins will be great. Paper clips, wooden items, plastic. All right, and then what you're going to do is what's great about these is you can, for bigger items, you can expand them, and for small items, you can bring them together. And you're going to, let's take the metal paper clip, this big metal paper clip. You're going to lay it so that it touches both so that touches both the metal tops. And as you can see, the light bulb flickers, but it comes on. So this is a conductor. So I'll put this on this side. All right, what about this? The screw looks like a brass screw. So I can, once again, put it over the two metal tops. And as you can see, it flickers. So this also conducts a circuit. What about a penny? So a penny is a smaller item, so I can bring these closer together like that. Place the penny over. And once again, the penny does conduct electricity. You see the light bulb flickering. What about a Lego piece? Lego's made of plastic. I put this over, but as you can see, the light bulb doesn't come on. So anything that's not a conductor would be an insulator. So that will go on that side. So you try different items, find about 20 items in your house. And then what you'll do on the last slide is you'll make a list of items that are conductors. So if I exit this and I come and I zoom in, if I click on the number 1, I can type metal. Oops, I spelled that wrong. A metal nail. I can put down here, if I click on number 2, penny. For insulators, a Lego brick. So that will go on the side that didn't light up the bulb. So conductors are items that complete the circuit, so the light bulb came on. Insulators do not complete the circuit, so the light bulb will stay off. So you're going to try to fill these up, try to find, as many as 8 insulators and conductors. And that's your assignment for the snap circuit activity, LED circuits. Have fun and enjoy. Bye now.